Good morning to everyone. Myself, Dr. R.C. Chauhan, Associate Professor, Samrat Prithviraj Chauhan, Government College Hospital. For the MSc Physics Semester 4th, we are discussing the Microelectronics Unit 2nd. The chapter is Parametric Amplifier, and the topic for today is Parametric Up Converter, PUC. This is not PUC, position under control, but it is the parametric up converter. What means of this parametric up converter? This is an applied part of the parametric amplifier. What is going on in it? So this is a special case of the Monley row relations we have discussed earlier. The case of the parametric amplifier for which the input frequency is Fs and the Fp. Fs, frequency of the signal generator, and the Fp is for the pump generator, but the output frequency is only the Fs plus Fp and also the Fs and Fp. So there is no power flow in the parametric amplifier at the frequency other than the signal, pump and the output frequency, that is Fs and Fp. Only that these three frequencies are there, and this such type of the converter or the parametric amplifier is called PUC, parametric up converter. Mostly a diode is used for this one, and also the non-linear reactance is also there. So this will be used as a PUC. So now the different parameters related with the PUC. First is the output voltage. Yes, earlier we have supposed that the voltage of the signal generator is the real part of the Vs e raised to power iota omega st, and this also can be written 1 by 2 the Vs e raised to power iota omega st plus the Vs star, that is complex conjugate of the Vs e raised to power minus iota omega st, and the similarly Vp, and then Vo is related with the output voltage, that is the real part of the Vo e raised to power iota omega t, and this is equal to 1 by 2 Vo e raised to power iota omega t omega 0 t plus the Vo star e raised to power iota omega o t. And the current related with this one is that we can write I equal to dq by dt and q equal to Cv. So on rearranging the different parameters, we can write Is equal to e raised to that is iota omega s cu Vs plus iota omega s cu m Vo, and similarly the Io, that is iota omega 0 or the iota omega o cu Vo plus iota omega o cu m Vs, where the cu is the capacity and m is the parameter to the pump voltage related with the parameter of the pump voltage. Now the next topic is to calculate the power gain. The maximum power gain for the PUC equal to the Fo divided by the Fs plus 1 by root of the 1 plus x power square whole power, where Fo is the output frequency Fs plus Fp, and the x is the parameters related with the gamma q, and this is equal to the Fs by the Fo multiplied by the gamma q square, and the q is 1 by 2 pi fcc rd. Rd the series resistance of the PN junctions, then gamma q, this is very important property related with the parametric amplifier, and this is called the figure of merit for a nonlinear capacitance, and the x divided by square of 1 plus root of 1 plus x, that is called gain degradation factors. In the special case, according this equations, we can write if the Rd is 10 to 0, means the resistance for this one is series resistance of the PN junction, that is 0, of the diode is 0, then the gamma q will be the infinite, and the gain degradation factor is also equal to unity, and the gain for a PUC for a lossless the vector diode is the Fo by Fs as predicted by the MR relations earlier we have calculated. This is a possible circuit diagram of the PUC. where L are the inductors and the C are the capacitors are the resistance connected, and this is the Vs and the Vp is there, and the output is the one, the V output VL, we can say load, the output as measured at RL. So this is the circuit diagram for this one. This is equivalent speaker of the PHC. Now we want to calculate the next property of related this PUC, and this is called noise figure. What is the ratio of the noise? So this is F equal to 1 plus twice TD by the TU multiplied by the 1 divided by gamma Q plus 1 by gamma Q whole square, where TD is the diode temperature in Kelvin and the TO is the ambient temperature of the 300 Kelvin. Mostly this is treated as a room temperature. And for the case of the microwave diodes, gamma Q is nearly equal to the 10, so the FO by the FS is equal to the 10. So and TD equal to, we have supposed this is 300 Kelvin, so the minimum noise figure is 0.90 decimal, which is less compared to 3 to 4 dB of the TWT. So we can say this PUC is more effective for the communications, having a low noise figure in comparison of the TWT. And the second properties that related with this one, so that the lesser value of the noise figure is in the para amplifier is due to the fact that the pure reactance will not contribute to the thermal noise. Now the next property, that is bandwidth. Bandwidth mostly we know very well, that is in between the two upper frequencies f2 minus f1. So here that is bandwidth of the PUC is given the bandwidth equal to twice gamma root of the f4 divided by the fs. For the microwave diode case, f4 by fs is nearly equal to 10, so in gamma equal to 0.2, that gives the bandwidth equal to 1.264. So this is a broad bandwidth for this one, and this is useful for the transmission of the bypass filter for the large, because of this one means we can pass FO plus FS for a large value of this one. So these are the merits related with the PUC. So this is sufficient for today. Thank you. We will discuss on the next.